Okay. Delaney, I'm writing down homework assignment. Hold on. Page 176.
8.
8.
10.
10.
16.
16.
18.
18.
26.
26.
34.
34.
44.
44.
54.
54.
58.
58. Oh, that's not too bad. That's not too bad. Okay. All right. Quadratic functions.
We're going to put that on the pen.
Yeah. Okay. All right. Quadratic functions. That's what this section is. We've talked about quadratic functions already. What does he look like? What's a quadratic function look like? What's his parent function? Let's start with there. Y equals x squared. What does he look like? Abel started to do it.
Smile.
A parabola, either a smile or a frown, right? How do you know whether he's a smile or a frown?
Negative or positive.
Negative or positive. Okay, so parent function, like if I strip away all of the numbers, he's y equals x squared. But a lot of times he looks like standard form, which is y equals a x squared plus bx plus c, right? Okay? And we use the ABC stuff. He's a trinomial, right? We use the ABC stuff when we're doing the quadratic formula. Have we done that already yet this year? Yes? Okay. Now, A has to be positive or negative. That will tell me if he smiles or frowns. I don't care about B and C. A determines whether he smiles or frowns. Okay? All right. We have some important information or some important things about a quadratic function, and one of them is this guy, which is called the vertex. Do we know that? And then we have something also called the axis of symmetry, which is like the line down the middle where he's folded in half, right? Okay. And the axis of symmetry will always go through the vertex or the middle, right? Okay. Yeah. Axis of symmetry always goes through the vertex. Okay. Now, how does this relate to, are you guys in physics? Yeah, so you guys have done projectile motion probably already, yeah, where you do parabolas and stuff, right? If you're shooting a basketball, that's a parabolic motion. A quadratic function is often used to model a projectile motion. This motion is followed by an object influenced by an initial force and the force of gravity. Do you know what the force of gravity is?
9.8.
9.8 meters per second squared. Do you know what that is in, like, feet per second?
No.
16.
16 flat.
It's actually 32, but the acceleration is,
Just always use 9.8.
yeah. Yeah, it's actually 32 feet per second, but then when you're talking about acceleration due to gravity, it's 16. So 16 will show up a lot in some of these formulas just because they're in feet per second and not 9.8 meters per second. Got it? If you take 9.8, like there's 3 feet in a meter-ish, right? So like 9.8 is the equivalent of 32, but then when you do acceleration, or velocity. Acceleration is 32, but velocity is 16. Derivatives.
So 9.8.
Right, 9.8 meters per second squared, 32 feet per second squared. This is the acceleration. Okay, but then if the acceleration is 32 feet per second squared, then the velocity is 16 feet per second squared, or feet per second. This is what velocity is. It's all derivatives, which is calc stuff. Okay, so acceleration, velocity. If you see 16 feet per second, that's just velocity. It has to do with 9.8, but it's in feet per second. Okay, got it. All right, quadratic functions, we just said ax squared plus bx plus c. You can also write a quadratic function in what's called vertex form, okay, which looks like this. Woo! Okay, and then we also have another form which is called, what do they call it? I call it factored form. They call it something. I don't know. Okay, so the 3 forms that I have standard form, write this down, standard form, I have vertex form, and then I call it factored form. They might call it something different. I don't remember what they call it. Factored form. Okay, so standard form, for example, is like x squared plus 5x plus 6. Right? If I write that then in factored form, that would be, actually, can I pick a different one?
Yeah.
Let's go 6x plus 5, just because. Okay, x squared plus 6x plus 5. If I write that in factored form, that would be x plus
3 plus 2.
x plus
5 and 1.
5 and x plus 1, right? I'm trying to multiply to get 5, add to get 6, okay? All right, now, vertex form looks like this, like x plus or minus something plus something, right? So the hard part is, how do I go from like standard form or factored form to vertex form?
You have to find the x and the y.
You have to, are you ready for this one? Complete the square. But the deal here is, we are going to complete the square, but we're going to do it on the same side of the equal sign, okay? So I have x squared plus 6x plus blank plus 5, and because it's on the same side of the equal sign, I'm going to go minus blank, right? Because if this is all on the same side of the equal sign, if I add a number, I have to then subtract a number, okay? All right, so here's the deal. This is what my trinomial is going to be, okay? So I want to multiply to get some number, which I don't know what I'm getting here, but then when I add them, I want to get 6. Oh, yeah, yes, but what's the thing, right? What goes down here? X plus 3 squared, right? Because 3 plus 3 is 6, but 3 times 3 goes in the blank, 9. And if I add 9 there, I have to subtract 9 there. And this would then be minus 4, okay? Now, the really handy part is, now that I have it in this form, I can easily find the vertex. And the vertex is -3, -4. That's my vertex. It's very easy for us to find the vertex when it's in vertex form. Now, when you're finding the vertex, what's true? The opposite sign of the one that's in parentheses, right? So +3 becomes -3, and then this guy stays, right? Because it's the opposite sign of just the one in parentheses. So the vertex is at -3, -4. So I can easily tell, like, some things, right? Okay, so here's what I can tell. Standard form, vertex form, factored form. Ready? I can graph this thing, and I know the vertex is at -3, -4, which is here, right? -3, -4. Something like that, right? That's where the vertex is. Where is he going to touch the x-axis? -5 and -1, right? Because factored form is really nice to find that element, right? So -1, -5, and it looks like that. Okay? This guy looks the easiest. This guy looks the easiest, but this guy is the best for finding the vertex when he's in that form, and this guy is the best for finding the x-intercepts. Got it? So, same thing, but just written 3 different ways, right? What's up? Look at you. You got them all. Cool. Okay, that's all we need. What? Leave them, and I might line up. Well, I don't know if I want to line them up until we get in there because they move.
I would just
Okay, you can take them back down to the art room. Okay, and I'll line them up, and then we'll just do like normal, like, I'll line the whites up, you put the blues on. Okay? All right, good? Got it? So, there's that. All right, analyzing graphs of functions. Determine. Here is this. Oh, what form is this in, by the way?
Oh, it's been 20 minutes.
He's in vertex form. We'll do a couple more and then we'll be done. He's in vertex form, right? Okay, what's the -2 doing off the front of him?
It's like
It's vertically stretching, but that does not change the vertex at all, right? It just makes him taller. Got it? And the negative flips him down. But this is still in vertex form. Okay, so part A says determine whether the graph of the parabola opens upward or downward. Down, because it is negative out in front, right? Okay, identify the vertex.
1, 8.
+1, +8, right? Because you only flip the sign of the middle one, right? The one inside. Okay, now it says determine the x-intercepts. Boo. Let's do D first. How do you find the y-intercept?
X is 0.
Yeah. So you plug, we can do C first, it's fine. We plug 0 in for y, we plug 0 in for x. We plug 0 in for the opposite one. Okay, so we'll go ahead and do C first. I don't think D is going to be any easier. If I plug 0 in for y, I've got 0 equals -2 x minus 1 squared plus 8. Now what the heck do I do? What am I solving for?
Square the
Not yet.
x.
Nope. Nope. Nope.
What x has to be?
-8 over. -8 equals -2 times x minus 1 squared. Then what?
Divide by 2.
Divide by -2. That is how much?
4 equals.
4 equals x minus 1 squared. Then what?
Square root.
Take the square root. What is the square root of 4?
2 plus minus.
Plus minus 2.
Ew.
Ooh, x minus 1 falls out. We have plus minus 2. All right, now, here's where you get stuck. You add the 1, and you add the 1, okay? So a lot of people say the answer is x equals plus minus 3, and that is not true.
It's either positive 3 or
It's
negative 1.
positive 3 or negative 1. If x is positive 2 and I add 1, your answer is 3. If x is negative 2 and I add 1, it's negative 1. It's not plus minus 3. Does that make sense? Okay? So those are your two x-intercepts. Usually you will have 2 of them. Okay? Not always, but usually. Okay? Y-intercepts. If I plug 0 in for x, I've got y equals negative 2 times 0 minus 1 squared plus 8. And now I just do the algebra. What do you do first?
8. No.
No.
Ooh.
0 minus 1.
0 minus 1 is negative 1. Negative 1 squared is
1.
1. Negative 2. Excuse me, negative 2 times 1 is
Negative 2.
negative 2 plus 8 is 6.
So y equals.
So he's going to touch it 6. All right, sketch the function. Whoop. Just make him up over here. The y-intercept, 1, 2, 3, 4, 5, 6 is here. And he's touching at 1, 2, 3 on the x-axis and negative 1 on the x-axis. Is the y-intercept, is that 6 value? Is that the vertex?
No.
No. The vertex is on which side of him?
The right.
A little bit to the right. So he does, in fact, go up a little bit higher there than that one, right? Oh, shoot, we know what the vertex is. What's the vertex? 1, 8?
Yeah.
Okay, so he should be like right here. Beep. Whatever. 1, 8. Okay, there's that. Sketch the function, done. Determine the axis of symmetry.
X equals 1.
Yeah. I'm kind of picky when I'm talking about axis of symmetry. He goes through here. Don't just say 1 because 1 is a point. This is the line x equals 1. Got it? Okay. Determine the max or min. He has a max at where? Yeah, the maximum value is 8, right? So you could say 1, 8, but the highest, really when they're asking for maximum, they just say what's the highest he goes, and the highest he goes is 8. Okay. Domain, range. Okay, domain is left and right.
Negative infinity.
Negative infinity to positive infinity, because that's interval notation. He will go left and right forever. Range. What's the lowest he goes? Negative infinity. What's the highest he goes? 8. There you go. There's your range.
But
Okay.
do you put a bracket on?
Oh, yes, bracket on 8. I'm sorry. Yes, because he will, in fact, touch 8. Now, when you're dealing with a quadratic function, will your domain always be all reals? Will you go left and right forever for a parabola?
Yes.
Unless it's the parabola's on its side. But this whole chapter is just x equals y squared, or y equals x squared. Okay? So, domain will always be all reals. Range will be either negative infinity to something or something to infinity if he's going up, right? Okay, so that's how that works. Got it? All right, let's do one more and then we will stop, okay? This guy is in what form?
Standard.
Standard form. Ooh. Standard form. Gross. Okay. Oh, that's making my eyeballs water. Making your eyeballs water?
It's like on the back of my front teeth.
It's on the back of your teeth?
It's messy with your teeth. It smells.
And we'll just pray that
It's
he
like-
cut all the way through.
And like it's like not pleasant.
Oh.
Like it.
Okay.
It's like a gut wrenching,
Gut wrenching.
like
This
skin piercing.
skin piercing.
Oh, okay. All right. We got to put this thing in vertex form. How do I get from here to vertex form again?
Do the
I don't know.
complete the square
Wait.
thing.
Okay.
Yeah.
Do the complete the square
I
thing.
don't like completing the square.
Oh gosh. Oh gosh. Okay. All right. You ready? Here's what we do. And this is going to look really funky weird because we have a 3 here. Okay. So just bear with me. Are you ready?
Divide everything by
Divided by 3.
Here's what we're going to do. We're going to pull that 3 out in front like the A. This is very tricky. Are you watching? We're going to pull the 3 out in front, and he's going to be treated like that A part, okay? So the 3 is going to go out in front, and if I do that,
That's 4x.
then it's x squared plus 4x plus blank, and then the 5 is going to go out here. Now, notice that the 5 was not divided by 3, true? So that's why the 5 is on the outside, but then I have to do minus blank here, right? Do you understand why it's plus and minus?
Yeah.
Because we're on the same side of the equal sign? All right, here we go. The 3 is just gonna chill. That 3 is just gonna chill. Okay, what goes in here?
Oh yeah, 2.
Right? X plus 2, right? X plus 2, because 2 plus 2 gives me 4, but what's 2 times 2?
4.
Also 4. All right. Trivia question. What goes here?
4.
Not 4.
2.
2.
No.
12.
What?
12.
Ah, sigma.
Why 12?
There's no way.
Because 3 times 4 is actually, you're actually adding 12 right here. Do you see how that works?
It's not real.
Okay, because that 3 is on the outside. But, so, minus,
Oh, sigma.
minus
5
Oh,
minus 12.
7. There we go. That's vertex form.
Wait, is 4x you're multiplying to get that? And then, wait, which one's the adding and which one's the multiplying?
You're multiplying to get this guy, and you're adding to get this guy.
Okay.
Yep. Okay? Because you add the middle 2 pieces together when you FOIL. Yeah. Okay. All right. Do we get how we got that? Kind of. That's a stretch.
Just a little bit.
It's all right. It's just a little bit of a stretch. All right. So y equals that guy. That's our vertex form. That's A. Woo! Okay. What's the vertex? B.
-2,
-2, -7. All right. The x-intercept means that we plug 0 in for y. Okay. 0 equals 3. X plus 2 squared minus 7. Oh, gross.
Add 7.
Add the
We're gonna
7.
do this on our test.
7. Okay. 7's over there. Now what?
Divide by 3.
Divide by 3. That's disgusting.
So
Okay. We'll just leave it as 7 over 3 equals x plus 2 squared. Take the square root. Let's just leave it as a square root of 7 over 3. That's disgusting. So, but we need
something.
plus minus, right? And then what?
Add 2,
Subtract 2, right? Subtract 2. So how do I write the answer? X equals
Minus 2
-2.
-2 plus minus the square root of 7 over 3. How many answers is that?
2.
2, right? We could actually like do that in our calculator and get 2 decimal answers. We're not gonna. We're just gonna do it like this. -2 plus minus the square root of 7 over 3. And we're gonna call it a day for that part. Okay, now the y-intercept. Okay, this is where the tricky part comes in. Because you look here and you're like, the y-intercept is -7.
No, it's 5.
But this is vertex form.
It's 5.
The y-intercept is not -7, yeah? If you go to standard form, it's 5. Y equals 5.
Yay!
Yay!
We didn't even have to do work.
Right, right. Okay, sketch the function, blah, blah, blah. He's something like this, and whatever. -2, -7. Is he smiling? Yeah, he is, right? -2, -7. The y-intercept is 5, right here, right? -2, -7. All right, you know what I'm going to do? 1, 2, right there also. Do you see that? You see what I just did?
What?
I just created a new point. This is the vertex right here, right? And 2 units away, he's up here at 5. That means 2 units away from there, he's also up at 5, and that's what he looks like. I didn't even use the x-intercepts to graph that thing. The x-intercepts must be these 2 things right here, whatever, right? That's what he looks like, okay? Axis of symmetry, this guy right here. X equals -2, right? He goes through -2 on the x-axis, okay? Determine the minimum or maximum. Will he have a max or a min? Min at, like,
-7.
they're saying what is the lowest he goes. So yeah, -2, -7 is the min, but when they ask for a minimum, they just ask for what's the lowest. So we only need the y coordinate, which is -7. Got it? Domain and range. Domain,
All reals.
all reals, -infinity to +infinity. Range, lowest he goes is
-7.
-7 bracket to
Comma, infinity.
infinity per n. That was really fast. Do we see what we're doing here?
Yeah.
Sure.
Woo! Okay. All right. We'll stop there.
Can I go home?
No. Can I go away? All right. There we go. Hey. All right. That's not too much. That's not too much left. All right. We got it. We did a generous helping today. All right. Bye, Delaney.
We did do a generous.
We did do